Remember this report? The one that implied that Reno had the 5th worst tap water in the U.S.? Well, that wasn't the whole story. If you look at the actual list, you'll see that in actuality, among 100 cities in the U.S., Reno has the 5th worst tap water. Yes, it's still not great, but certainly better than being 5th worst in the entire country. Failing to show the whole table is an example of data distortion, one way of misinterpreting data. That's what we're looking at today, misinterpreting data. Data can be misinterpreted for a variety of reasons. One of these is allowing your opinion to bias your interpretation.
It's a scuba diver's paradise, the island nation of Palau. Divers come from all over the world to view Palau's stunning population of reef sharks. Increasingly, though, it's the sharks that are the prey of humans. Shark fin soup is a delicacy in many Southeast Asian countries. Boats from many nations come to fish Palauan waters, and many leave with holds full of illegal shark fins. Although this criminal activity is profitable to foreigners who can earn up to $100 per dry pound, it is a major concern to Palau natives, including shark activist Ron Lydek.
These fishing vessels are licensed for tuna and tuna-like species. Look at this hole. There's no tuna in here. This is all shark fins. Oh, man.
Lydek has observed what appears to him as overfishing of the Palauan sharks and a steep rise in the number of sharks killed in Palauan waters each year. His view influences and is influenced by his active work on behalf of worldwide conservation efforts. It's a kind of bias, in this context, a prior view or perspective that influences how he interprets information.
A second way we can misinterpret data is through measurement error.
For example, suppose this wrestler weighs himself on a scale at home, and it shows he just made the weight class for his meet. But when he weighs himself at school, the scale shows he's overweight for the competition, and therefore disqualified. What happened? The scales may have been calibrated differently. One or both may have been inaccurate. This inaccurate calibration can result in measurement error.
And a third way is by display distortion.
In the sunny states that attract young people on spring break, is it always warm and sunny in early spring? Maybe not always, but could the weather reports be presented to make the situation seem more consistent than it is, especially in anticipation of tourist season? Suppose people in sunny southern states wanted to attract more visitors. They could use display distortion to graph the state's daily maximum temperatures. Any image that presents data or results in a way that can be misleading can be considered an example of display distortion. This line graph seems to show that the weather in Florida, as reflected in temperature, doesn't change much, but look more closely. The graph shows the pattern of daily temperatures 1 March, including spring break time. Dates are on the x-axis, temperatures are on the y-axis, in 10-degree increments starting with 0 and ending with 100. With this scale, the fluctuations ranging from 71 degrees to 89 degrees seem minor. That is, in fact, the range of daily maximum temperatures found in Florida during a month of March. But watch, what if the scale of the graph were changed? The y-axis no longer shows a range of 0 to 100. Instead, it displays a range of 70 to 90, showing more fully the fluctuations spanning 18 degrees. The steps between the grid lines are now only 2 degrees instead of 10. See the difference? The data is the same, but this graph shows what looks like much greater fluctuations because the range of the y-axis changed. So, you see the data differently. Graphs can be used to minimize or emphasize changes, depending on the purpose. And data can be accurate, but may be presented in a misleading way. How it's displayed can have a big impact on how it's interpreted. Now let's switch gears to music. People typically have a favorite type. Suppose a music download site on the web wanted to compete with the leader in the industry. To lure customers, they advertised that their recent survey of teenagers found that they're the company that sells more popular music than any other. Say they displayed their results in a circle graph. 8.4% of teens surveyed said they listen to alternative music. 1.7% said they listen to country music, 49.2% said they listen to hip-hop music, and 40.7% said they listen to rock music. A circle graph compares the amount in each category to the amount in the whole data set. So in this case, each type of music would be represented on the graph, totaling 100%. But what if we displayed a circle graph that included only alternative, country, and rock music? It would look very different. Visually, the graph looks like it totals 100%, but because hip-hop music is not included, the percentages representing the other types of music, especially rock, appear exaggerated. Our message: in reading graphs, you need to look past the visual presentation, know the context, and read the numbers to understand the situation.
To summarize this last little video clip, when reading graphs, look past the visual presentation, know your context, and read the numbers to really understand the situation. That's it for this video. You have a little bit of practice. Remember, if you're not sure what you're doing, check with a math teacher near you.